Today's topic is DFT properties. So there are around 14-15 properties are there. We will study one by one. All DFT properties are important. Examination point of view, they may ask like state and proof DFT property or problem with the help of property. So property can be DFT or inverse DFT, either way. So problems using properties also equally important. All the properties inner meaning, concept behind that you should know. So word statement, mathematically how we express, how do you prove it, how to apply that property, solve the problem fastly. So that is the significance of these properties. So let us go one by one. All these properties are similar to Laplace transform. Laplace transform already you have studied in S domain. Z transform, all properties I already explained in terms of Z, and DFT properties in terms of K. So variable only K, but conceptually same. The way how we are proving also more or less same. So similar way it will come. But however, examination point of view, they may ask in either in Z domain or DFT domain. So ax1n plus bx2 of n DFT is A x1 of k plus b x2 of k. Always frequency domain, letter is capital, but variable is always small letter. Okay, this is one simple, no need to prove it. The second one is periodicity. That is x of k plus n is equal to x of k. N is the period. So sequence is a periodic, its transform also periodic, and after a period of n, same sequence will come. That is the meaning of this. Then third one, time shifting. X of n minus n naught DFT is x of k e power minus j 2 pi by n, and here it is frequency domain k and shifted with n naught. So time domain shifting by n naught, frequency domain multiplied with the exponential is the time shifting property or linear shifting. How do you prove this? Prove this. So DFT of x of n minus n naught is equal to sigma k equal to 0 to n minus 1, n equal to 0 to n minus 1, x of n minus n naught, and this is e power minus j 2 pi by n k. Just a formula I have written. Now let n minus n naught is equal to m. N equal to 0, so m equal to minus n naught. Here n equal to n minus 1 minus n naught, that is n value, x of m e power minus j 2 pi by n and k. What is this n value is m plus n naught. So we can also change minus n naught to this. So I can remove this and this. It is nothing but same as m equal to 0 to n minus 1 x of m e power minus j 2 pi by n mk into e power minus j 2 pi by n k into n naught. What is this term is? This is similar to DFT formula. If you want, you can change m equal to n equal to 0 to n minus 1 x of n e power minus j 2 pi by n k. So variable m or n same. So this is nothing but x of k minus j 2 pi by n k n naught. This is what RH is. So easily we can prove by substituting n minus n naught with n. This is what time shifting. So time domain shifting, frequency domain multiplying with the exponential. Property convolution. Y of n equal to x of n star h of n and y of k equal to x of k h of k. So time domain convolution, frequency domain multiplication. So how to prove this? DFT of x of n star h of n is equal to sigma x of n star h of n Wn nk. Here n is changing from 0 to n minus 1. Just DFT formula I have used. This you expand 0 to n minus 1. What is this expansion? X of k h of n minus k. Here k is variable changing from 0 to n minus 1. This I am writing Wn nk. Now change the order of summation. K equal to 0 to n minus 1 x of k take it out. Now n equal to 0 to n minus 1 h of n minus k Wn nk. So we can, this is nothing but time shifting property. This is the DFT of h of n minus k. Or otherwise this k confusion. So x of m h of n minus m equal to 0 to n minus 1 Wn nk. So this is x of m equal to 0 to n minus 1 h of n minus m. Because this and this is different. So using time shifting property, m equal to 0 to n minus 1 x of m, h of n is shifted by m. So what we get to h of k e power minus j 2 pi by n km. Using time shifting property. So straight away, previously already this proof done, using that we get this. So this is nothing but h of k sigma m equal to 0 to n minus 1 x of m, this is nothing but wn mk. Now if you want, you can change variable from m to n. So this is nothing but x of k. So what is the answer now? H of k into x of k. These are answers. So DFT of this is nothing but h of k into x of k. Time domain convolution, frequency domain multiplication. So this is how we can prove it. Fifth one, x of n, h of n. Here time domain multiplication, frequency domain convolution. Time domain multiplication, frequency domain convolution. So take RHS and prove it. So this you have to expand first. IDFT of x of k star h of k. This is in frequency domain. I am finding inverse of this. You will get time. So what is IDFT formula? IDFT formula 1 by n sigma k equal to 0 to n minus 1 x of k star h of k into wn minus nk. Just formula, IDFT formula every time. This is nothing but 1 by n k equal to 0 to n minus 1. This you expand, convolution. So when we are expanding some dummy variable x of lambda, h of k minus lambda, and lambda is changing from 0 to n minus 1. Just this I substituted here, minus n. Now change the order of summation. Sigma lambda equal to 0 to n minus 1 x of lambda, then sigma k equal to 0 to n minus 1 h of k minus lambda, wn minus nk. Okay. Sigma Now k minus lambda equal to m. 1 by n sigma lambda equal to 0 to n minus 1. K equal to 0 means m equal to minus lambda, n minus 1 minus lambda, h of m wn minus otherwise e power j 2 pi by n so k replaced with m plus lambda. Okay, so this is further 1 by n 0 to n minus 1. Here minus lambda we can remove, 0 to n minus 1. Then h of m e power j 2 pi by n mn here x of lambda then e power j 2 pi by n lambda. So if I take 1 by n here, this 1 by n, this term, this term, this term, this term. So sigma lambda equal to 0 to n minus 1. So this is nothing but h of n. Then e power j 2 pi by n lambda. Okay. So here again we want 1 by n. Again n. So this is nothing but n. H of n. This and this is nothing but x of n. So we started with this n into x of n, h of n. This is LHS. This h of n written and 1 by n lambda 0 to n minus 1 x lambda e power j 2 pi by n lambda. This lambda you can change k also. K equal to 0 to n minus 1 x of k e power j 2 pi by n k. Similar to IDFT. So that is nothing but x of n. This is h of n. This and this. This m can be changed to k also. K equal to 0 to n minus 1 h of k e power j 2 pi by n then nk. So this is nothing but h of n. So just be careful in writing the formulas. So we got LHS. You need lot of practice, otherwise you will do mistakes. So like this, I hope you understand how I would have. So this is the sixth property for any real valued sequence. Real part of DFT XR of K. So originally this is separated, e power minus j 2 pi by n k. So e power minus j theta is cos theta minus j sin theta. So this cos part is real, sin part is imaginary. So how to separate DFT real part imaginary with the help of formulas. Then x of k is always x star of n minus k. X of k equal to x star of n minus k. This property is very, very important. X star n minus k. If it is a 8-point DFT, you need not really compute 8 points. You can compute off, remaining off we can find with the help of symmetry property. For example, if n is equal to 8, n equal to 8, this is 0, 1, 2, 3, 4, 5, 6, 7. So what is n by 2 is here. This is center. These two are complex conjugate. These two are complex conjugate. These two are complex conjugate. That means if you know DFT at 3, you can find 5 just by taking complex conjugate. For example, DFT at 3 is 3 plus J4. This will be 3 minus J4. If I to 2 plus J2, this will be minus J2. That means how many we are finding? 0 you have to find, 1, 2, 3, 4 you have to find, 5, 6, 7 will be complex conjugates of at 1, 2, 3. These values just complex conjugate, you will get it. So that is the powerful advantage of this statement. So real component is symmetric. So if you fold, if this is 3 plus J4, this is 3 minus J4, but 3 is same only, na? But this is plus J4, this is minus J4, anti-symmetric. So real part is symmetric, imaginary part is anti-symmetric, about n by 2. That is the meaning of this explained here. But if n equal to 7, for n equal to 7, again 0, 1, 2, 3, 4, 5, 6. 0 to 6 means 7 values. Now here center will be between, what is n? 7 by 2. 7 by 2 is 3.5. Here 8 by 2 is 4. So center point is at 4. Here center point is at 3.5. So this 3, 4 complex conjugate, this 2, 5 complex conjugate, 1, 6 complex conjugate. So you have to find 0, 1, 2, 3 enough to find 4, 5, 6. This is n equal to odd number, here n equal to even. Even it is exactly at 4, but odd here 3.5. So based on this n value, you can easily compute DFT values easily with the help of this property. Okay. Next, real part is even. Cos is a even function. Imaginary part is sine, so sine is a odd function. And magnitude of x of k is even. Mod is even. But angle is odd. Angle is odd. If x of n equal to x of minus n, even sequence, then DFT is the real. DFT is real. If x of n equal to minus x of minus n, sequence is odd, then x of k is purely imaginary. So based on the type of sequence, DFT will change. So this is one concept, this is one concept. So these are all small points, all comes under one property. So next we'll see this is another property, x star n sequence complex conjugate. Its DFT is x star of n minus k equal to x star of minus k. How to prove this? DFT of x of n is x of k. So what is the formula? Sigma n equal to 0 to n minus 1 Wn nk. So DFT formula I have written. So let us find x of n minus k. What is x of n minus k? K I am replacing with n minus k. So sigma n equal to 0 to n minus 1 x of n Wn n minus k. So this is nothing but n equal to 0 to n minus 1 x of n. N will go Wn minus nk. This is x of n minus k. Then what is x star of n minus k? So when I take complex conjugate, this side also we should take it 0 to n minus 1 x star of n. What is the complex conjugate of this? Nk. So x star n minus k answer is this. Now let us take x of minus k. This I am rewriting x of minus k. In place of k, write minus. So n equal to 0 to n minus 1 x of n Wn minus nk. Then again take complex conjugate x star of minus k. So sigma n equal to 0 to n minus 1 x star of n Wn nk. So when I take complex both the sides, this is complex, minus become plus. This and this is same only, na? This and this is same. Therefore, x star of n minus k equal to x star of minus k. This proof done, but this is equal to DFT of x star n. What is this one? It is like a DFT formula for x star of n. So DFT of x star of n equal to this. This is same as this. So like this we can prove the property. So remaining properties I will continue in the next video. So all of you please subscribe to this channel, my YouTube channel, and also share to your friends. If there are any doubts, please express in the form of comments. Okay.